Right now we're just starting to mix the mash up, and it'll be fine. Just the heat. Before I put the water in, I want to show you guys. That's a false bottom. Basically, that allows it goes to the bottom of the kettle, and it leaves a dead space or a false bottom below the screen. So when we suck the water out of here, when we draw the water out, it's going to come from the bottom, not from the top. So the grain, in theory, is going to stay up here, and the water is going to be clear. But it's not really going to be clear because we have such a fine grind in some of those mixes we made that it's going to settle through. We can fix that later, but we try to isolate what they call lauter the mixture as much as we can to begin with. Lauter means nothing but. Actually, that's direct translation. But so nothing but means we're just getting out the water. We don't want the grain. The other way we could have done it, especially on a small scale like this, we never would do this on a bigger scale. The other way to do it when they make beer is to just keep it in a steeping bag. You have a fine fabric bag, and you put all your ground grains in the bag, seal the bag, and drop it into the water. You don't need this then, because then the water makes a tea, and that's all it is. With the actual grain, you're getting full exposure. It'll make a perfectly good mix here. What I'm going to do is I just want to put this on the ground. May need to add heat to it.
I'm going to connect that?
Yeah, you can connect it. I'm going to rinse this out. Okay, what we're going to do now is put the we'll mix the grain in with the water at our ratio of we said about 1.33 quarts per pound. So it came out to
5 gallons.
Yeah, 5 gallons. Yeah, I wrote it down over there. So we can just put a little water in first. What I'm going to do is measure. This is hot, or warmed. I warmed it up to about 190 degrees, and it's come down since. So it's probably about 175 now, 170. Now, I guess the other thing I can say, I probably should just show you this, just to keep in touch with the thing I described before. We are going to be boiling this later, probably, but if I don't necessarily have to bring it to a boil. I can bring it to close to a boil. In fact, and I might do that, depending on how long it takes. So what I'm going to do is absolutely make sure we're just going to clean the inside of the container with this no rinse cleanser. And again, I mean, for beer, it looks yucky, and you want to rinse it, and you can certainly do that. But we're not going to be drinking it anyway, so just have to make sure everything's in here's done. It's going to soak down through the screen. We're going to do this while we're here. Yeah, it'll get on the false bottom. We can do up in here, make sure we got everything done. I think it's a pretty good job. Now we'll be measuring the pH as a mixture, because the water measures 6.1 when I put it in here. Once you put the grain in, it's going to change that. But I'm roughly at 6.1 pH, which is a little bit. 7 is neutral. We're going to put a little bit of water in here just to put something at the bottom. It's about 170 degrees, as I said. This is 2 quarts container. So that's half a gallon. With the false bottom, we need a little bit of water in there to start, because the water is going to fill the bottom before it reaches past the screen. And of course the pipe for the false bottom strainer is sort of in the way of the paddle, but we can't do a whole lot about that. It's just the nature. So that's 1 gallon. Probably put about 2 in. 1.5 gallons. And see, everything can be a little different, like not so much within the grains, although between corn and barley there might be, but like potatoes are going to be different in the amount of water because they already have water in them. The temperatures at which that's why I'm referring back there, because I'm trying to remember. Okay, well, barley's this and corn's that. I did a lot of work with corn, and that's sort of what I'm thinking, but that's not always the best. I think that's pretty good. Why don't we do light it now? Now that it's light enough, we'll light it up and just keep it on real low. I want to keep it really low because I don't want it too much. Okay, that's good. So what we're going to do is we're going to put the grain in, all the grain, and mix it up, and then we're going to take a pH reading, And we can adjust the pH. The pH has to be somewhere between about 4.5 and 7. 7 is the middle point. Anything below 7 is a little bit acidic, and everything above 7 is an alkaline or a base. The reason we're doing this is because the enzyme prefers to be down a little bit acid. So it can't go below 4.5, and it doesn't want to go above 7. So to make it more acidic, if it needs to be, we'll put in citric acid. It's a pretty benevolent, it's lemon juice type acid. We put in what we need to adjust the pH on that. And if it happened to need more alkaline, we just add sodium bicarbonate. That's a moderately strong alkaline, so that'll work. And one thing I didn't mention, because this is a well water, but Camden tablets. When you boil water and you're using city water, it has chlorine in it. We don't want chlorine in the water. It's not, beer makers certainly don't want it for taste, but we don't want it because it's going to affect the yeast and the enzymes. So, because chlorine is a cleanser, so it kills things. So we don't want that. So in the boil off, any of the water that was boiling, like before when we had it steaming off like that, if it would have had chlorine in it, a lot of it would have been boiled off. But these are Camden tablets, and you add these to further break down any chlorates in there to negate them or minimize them. So with city water or with sources of water that are chlorinated, you really need to be doing that. And you can do a chlorine test. You can also pass the water through a filter, just a activated carbon charcoal filter, and that'll keep the that'll strain out all the bad stuff, and it'll be pure water then. But this well water here, and actually for our purposes, the well water with the minerals that are in it is actually a better solution than say a distilled water or city water that's had its other stuff removed. For the beer makers, it imparts a taste. It actually has a better taste. But for us, it's just more active water. I mean, the minerals can be the minerals that would normally be safe to drink are also ones that would be beneficial to yeast and to especially to yeast mainly. So. Okay, so we put that in there. I'm going to put in the grains. That's that one. You can smell it, it's sort of nice here. We don't want it to clump up and get into a gelatinous mass that we can't stir. You can go and pour that one in too. You'll notice that the grains that were ground correctly are a lot coarser. They've just been really basically hulled, and our stuff is much finer. But I can't do a whole lot about it.
Pour this in anyway?
Yeah, just pour it in. Well, wait, maybe not yet because I just poured that little one. We need more water. I think this is 2 gallons, right?
Yeah.
Okay. It's not rocket science. We may end up putting 6 gallons or 7 gallons, or maybe not 7, but we'll. It doesn't have to be 5. That's starting point.
Container of water?
Yeah. Yeah, go ahead. Be careful of that when the spigot has to be, the little latch has to be undone first, and don't let it squirt out and burn your hand because it is sort of hot. Just fill it right to the top of the 8 ounce or the half a gallon mark. Got it? Okay. I can feel some of it's getting stuck under the pipe, so we want to get that out of there. Mm-hmm. This is going to take an hour. And then there's going to be some cooling time in another hour, so we're not going to see the results. What I'm going to do is I'm going to pitch the yeast for you and all that, but we're not going to see a fermented product. The fermentation takes days to finish. It may be 7 days before it's actually ready. So that's 2 quarts. Yeah, go ahead and stick it in there.
2.5 gallons.
2.5 gallons, right? Okay, and do another one for us. Go ahead and pour that in. Slowly, because I may ask you to stop.
Say when.
Yeah, it feels pretty good. I mean, go ahead and do about half of that. Go ahead and do all of it. It's not jelly. We're trying to avoid just dumping it.
Clumpage.
We're trying to avoid clumpage, exactly, and that can be a real issue. Whoa, go ahead and put the water in. Okay, let's get some more water. So that's 3 gallons now.
We're up to 3, yeah.
Yep. So let's get up to 4 gallons. I think our lowest end was like 4.5. I think that's what it came to, and I just made it 5 because of the extra 1.33.
Pour it in.
Yep.
Someone else is keeping track, right? Yep.
This is 3.5 gallons. Okay. Let's
You're about
do.
to make it 4.
Yeah. And I'm going to put. Yeah, you get your 4 in there, and I think you can take a stir at it. Just.
I
You know.
got this down.
Yeah.
Pouring water.
What a thing.
You're hitting the pipe, which you're going to do. I mean, just. Just keep it going and ride the top of that screed.
False bottom.
Go ahead and put it in there. Make it 4 gallons. Okay. Actually, you can draw one. You can draw one more pitcher and just leave it. We might need it. What does it feel like? Getting thick?
I don't know what to compare it to. I mean, it's not as thick as oatmeal.
No, it won't be that thick. Now quiet. Okay. Go ahead. I think I could see that we needed that. So that's all our grain.
So we're getting the starch out of the grain now, right?
There's a big clump.
Yeah. Oh, let's get that clump out of there then.
And I can't. It's hard to see it.
Yeah, where the starch is being taken out of the grain and converted slowly. Well, we haven't done it yet because the enzyme's not in. But our goal is to use that enzyme to convert that starch to a mid-level sugar or a long chain sugar, which the yeast cannot eat at that long chain. It's too big for it. Let me just feel what we got in there. Yeah, there's something in there. But what I've been doing is like passing it under that pipe by shoving it like that because it's drawing it under, and I think that clump is out of there. They can design these with the pipe that's not in the way. I mean, it's basically other ways of doing this, but this is like the simplest way to do it for a home scale. I mean, this is basically a brewing situation, not so much alcohol. I mean, this at this size. But I mean, if you were doing this on a regular basis, you make enough fuel. And it's not like it's just it would be time consuming. So was this 4.5 or 5? I think it's 4.5, right?
It's 4.5.
Yeah. Yeah, I think it was the last one. I just dumped that last one in. I mean, this is pretty, pretty okay.
Yeah. Looks great.
It's not. Yeah, right. It's not, breaking up yet completely because the enzyme's not added. But I mean, there's plenty of water in there, so that's fine.
So the consistency will clearly change.
It'll get thicker. Okay. Well, somebody stir that. And I'll take this pH test.
So if you had an activated mineral compound, added it to that, would that improve the alcohol yield, or would it just help the yeast?
It would just help the yeast function better. That's all. Which in turn would make more alcohol. Yeah, but it's not an amazing improvement. It's just better with minerals, yeah.
Primarily, it'd be good at making beer.
Well, that's what I was talking with him about. They always want to use spring water or well water for beer making because it has minerals in it.
Right.
I was always wondering with Camden tablets too. You're saying
It just dechlorinates. Yeah, it kills the chlor. It knocks down. It breaks down the chlorates out of their chlorate structure, and so they're not functional.
and does that go off as a gas?
Yeah, it just dissipates. Yeah, it just dissipates then. This is a pH meter. Okay, let's sample out.
They can tolerate those temperatures, huh?
Well, that's what I'm sort of thinking. I don't want to do is put it at that height. I don't know how high this goes. I mean, when I say height, I'm going to put it in another dish to cool it down. But I want to see if there's a limit on here. I just got this one a couple weeks ago, so I haven't really been using this one. I used to use litmus paper, which doesn't matter. Let's okay, we're okay at this point. We're going to check the pH level, yeah. And I just did a little check before. So basically, it's a pH meter. Measures between 0 and 14. The middle neutral is 7. It's an electric one. We used to use litmus paper, but it's so much easier to put this in. So this is automatically temperature controlled. It says ATC on it. That's why I bought this one. I'm letting it cool down a little bit because I don't want to risk, I'm not sure how high, if it can go into boiling water, which I don't think it wants to. So actually what I probably should do is measure that. Yeah, it's only about 95 degrees now, so that's not bad. So I'm going to take a reading on the pH, and it's, at this point, 5.55. It went down. It was 6.1 to start with the water, and then we put the barley in. 5.51. 5.51. So we're good. We're in a good place. We have to be between 4 and 7, or 4.5 and 7. So that's good.
So the final mixture, you're basically shooting for like 15-20% alcohol. Is that what you were saying?
Yeah, and we're not going to be able to observe that because I can't have enough time. Well, it takes 7 days to ferment actually. So, we would do everything we had to do. Then it just sits there, and it has to sit there for 7 days. And then if we all came back next week, then we could actually measure that. But I'm just showing what I can show you in 5 hours.
That's a good enough content to fuel a vehicle.
Yeah. Well, no. What's happening then is, this is what we're going to talk about. Then the still part comes in. We've got a solution that's 15% alcohol, and then we put it through the still, which is going to knock all that as much water as we can get out of that. So that 15 is going to go to 40, 80, up and up and up till about 94% alcohol. After that, 96 maybe, 95. After that, you have to put it through a special process, which is either a sieve, a molecular sieve, which is a sieve that's so fine that it actually it won't let the water through, or there's other ways of doing it with salt and stuff, but we don't really normally need to worry about that. At this point now, we got our pH is adjusted to 5.1, which is perfect. Very good. Right about in the middle. And the grain it looks to be pretty well mixed up in there and whatever. So we're going to put in the alpha amylase enzyme, the initial enzyme which is going to break down the starch particles into a long chain sugar. That's the first enzyme step. So we have measured it out earlier for this amount of water. So here we go. Put it in and just stir it, mix it up. Well, I'm going to put a little bit of this in there and empty that in. So, and now at this point, I've really got to make sure it got mixed in good and stirred in so it gets distributed.
Is there a temperature range that?
No, yeah, it's down low. We're down in the lower region. We don't want to get too hot on that. Let me see here. Can you stir it up? I was going to get my thermometer here. Let me just let it cool a little bit to get that. About 160. So we want to keep a limit on there, of about 165 of it on it.
Because too hot would break down the enzyme?
Yeah, it'll be not functional after that. So we're in good shape. Make sure that's down. Now we could cook. I don't want to take all night just doing this, but we could cook that before putting the enzyme in. And before putting that enzyme in, we could have boiled this if we wanted to, or bring it to a near boil. The temperature was hot enough to be able to do its thing. It's going to sit for an hour like this at a temperature below 165, and it can't go below 135.
So alpha amylase for 1 hour?
Yes. With agitation, but ideally, if this was a bigger vat, or if I had a system that was more automated, it'd have a little electric motor in it, and that would be agitating it all the time. With corn, as I said before, we were talking about bringing it to a boil. With corn, you would more than likely have to have this come up to a boil for a little bit, like 15 minutes, and then brought back again, or at least keep it at a simmering for a while. With the barley, it's not as important.
It's more important for the corn to break open the
the corn. Yeah, the walls of the cells there. But you can feel. You were doing it. You can feel it. Can you feel it starting to get more? You know, a little more thicker? Or we're starting to, gelatinize a little bit?
No, I'm not
Yeah.
that sensitive.
I can tell that it's sort of gelling a little bit more.
Okay.
Because what's happening is it's breaking it apart and distributing it in more, a little more evenly throughout the water. Let me rinse this off and then we can check on this. Okay, we're about the same. It hasn't really gone down much. Okay, we can probably stop mixing it because it can rest.
Leave this like this.
Yeah, sure, that's fine. What we can do is, I won't do it now because it's a little too early, but I'll show you what we do with the iodine test. The starches are, well, I'll bring it here and show you. I'm going to take a little sample of this, and it's a starch. Obviously, all the amylase hasn't had a chance to work. And what we can do is when you it's just regular tincture of iodine. When you put an iodine into a starch solution, it's going to eventually change color. So we're just going to be able to see by putting it in here at this point what we've got. See, it's brown. I mean, the way it should be. And then as it turns to a sugar, it's going to lighten up. That's just, we haven't done anything really. It's not ready yet, but it's still staying brown. That's what I'm trying to demonstrate. That
Whereas if the starches have been converted and you put iodine in it,
it'll be a lighter. It'll clear out. Yeah. So that's a way of testing the progress of things as we go along. So that's going to sit there for a while. Here's my meter. You take the opportunity to go in and talk about some of the other stuff at this point, because we can just sit there. We got the gas off. I will have to check, or when Pat comes back, or somebody will just check the temperature as we go a little more. It can't fall below like 135. So.
You want to put the lid on?
No, I think it's already a little higher than I wanted it to be anyway. I think I had assumed because of the earlier reading that it was, that the water was about right, but that water was a little hotter than I wanted, so it got up sort of hot. So I'll just leave it at this. It's 158 maybe.
cool down pretty quick out here.
It may. I mean, we check it.
Hey, you need me to be monitoring anything?
Not immediately, but after a little while, maybe
Okay.
5 or 10 minutes, we can check the temperature of this and see that it doesn't get below 135.
Okay.
I'm trying to crush apples now. So we're not going to get much juice out of this. I didn't, we're not going to get anywhere near what we'd really want, but that's not important. Really, I just wanted to show you the process. There's a measuring process and whatever. And we can pour.
You catch the juice in?
Yeah, I'm going to get that. Actually, it gets put in there first, and then it falls into the bucket. We can. Yeah. Oh, it is. Okay. Why don't you untie the second one? And I was going to see if I can get if this is low enough to catch the juice. I'm going to sanitize this one because it's going to have the juice in it. With a sweet juice like this, apples or any real sugar stuff, it will spoil quickly in the air and out. Just sugar-based juices spoil quickly. So I don't mean 15 minutes, but I mean they can't be stored open for days and days like like some of the other crops can, or even without refrigeration. So that's another thing to take into account if you're making alcohol, is if you are using a sugar-based crop, you need to process it into alcohol as quickly as possible, instead of like storing, having steps at which you spread it out over time. Let me get the bag.
Ready? Am I blocking the scene?
How are we doing?
Looks like juice. All right.
I'm not sure how tight to make this.
You're doing great.
No, but I don't want to break it.
I don't need to break it either.
I don't think it can break.
I think it won't turn anymore before it breaks.
Anybody have a feel for how tight this should be?
As tight as it can be, as long as the tray's not overflowing.
Let me feel of it. See how tight this one. I mean, I've used it before, so I know that. Let's let it rest for a little bit.
For this purpose, why even strain it? Why not use pulp and everything?
We are going to basically save time. I'm not going to strain it. You mean for the bag straining, or
all that stuff. Why?
Yeah.
Why?
Because if we were going to use a still, which I'll talk about in there, that's packed, you want the juice. At some point, you're going to have to strain it. And the strain and the juice actually is the yeast will work better on juice than it does on pieces of apple.
Okay.
You know, basically.
Right.
So. You know, because it's just like how big a piece of meat can you eat. I mean, you can't take a chunk, a 4-pound piece and digest it all at once. I mean, you have to cut it into smaller pieces.
If you were putting it through like the equivalent of grinder, so that you were really atomizing.
Yeah, right. That would be better.
Then ferment the whole.
Yeah, exactly. Yeah.
Then you'd have to strain it before putting it in the still.
Right. The other thing is think about the energy it's going to take to make it that atomized, to grind it to that level. You're going to have to put that much more power into it, energy somewhere. Electricity or horses turning a thing, or
When I make apple wine, that's what I start with, but then
Right.
I'm thinking about, well, why not put the whole stuff
Yeah.
in the first primary fermentation?
you can do that, but basically, like I'm saying, you'll be not breaking down and thus wasting the chunks.
Okay.
I mean, they'll break down to some extent, but you're still going to have, it's just hard for the yeast to
I
digest that.
thought the yeast was very tenacious through all the pores of the apple.
Well,
Maybe not.
it is, but it's still a big piece of it. No, we don't need to use enzymes so much with, we don't need to use enzymes really at all for nutrients, but not the enzymes only work with the starch or are needed for the starch. Okay, do a little more squishing. I'm going to check on this temperature thing again. I want to make sure we got the temperature consistent through the top and the bottom. It's not converting as quickly as I thought because I think it was a little hot at the bottom instead of the top when we first put the stuff in. So I'm just gonna mix it up a little better and let it set. Okay, how are we doing? Is it got enough out of it that you consider it? Okay. All right, we can go inside and we can talk about the sugar.